This conference will now be recorded.
Okay. Hi friends. So in this Azure Databricks master program, so with respect to Azure Databricks series, we are going to see today third session. In this third session, we are going to focus on Azure Databricks concepts. So once we know this Azure Databricks concept, then we are good to start our labs. Okay. So as part of today's session, we are going to learn what is interface and how many different ways we can able to access this interface, and what is workspace, what are the things we can able to access from the workspace, and data management. So what are the different so how many different ways we can able to manage data within the Azure Databricks. Next, computational management. So how we can create the cluster, and how we can create the like how we can start the cluster and stop the cluster in a efficient manner. So what happens is, in real time, if you start the cluster, it uses to take 5 to 10 minutes. Okay, if you are waiting that much time, it's kind of a time waste, right? So you can reduce the time for starting your cluster. So how you can reduce the time to start your cluster, all those things we are going to discuss with respect to computational management. Next, model management. Suppose you are implementing any models, machine learning models, so what all things we need to know, so that particular thing we are going to discuss. Finally, authentication and authorization. So whom we want to give what kind of access, then if we have given access to notebooks, what kind of access we need to give, whether we need to give read access, whether we need to give write access, whether we need to give the full permissions. So that kind of authentication and authorization. So we need to know all these concepts with respect to the Azure Database. Let's focus on interface. What is interface? Interface that Azure Databricks supports for accessing your assets. So kind of, suppose if you want to access your Databricks, okay, if you want to open your Databricks workspace, so what is that? You need to access the Databricks. To access in Databricks, you can access this Databricks by using user interface. That is nothing but a UI. Okay, by using user interface, you can access the Databricks. This is nothing but the Azure Databricks UI provides an easy to use graphical interface to workspace folders and their contained objects, data objects, and computational resources like cluster creation. What it means is, so we all know, if we are doing something graphically, it will be easy for us because we can able to see what we are doing and what we are clicking. So if you want to do something, it will be little bit easy for us to see something graphically and doing some actions, right? So this is the one of the way, by using this UI, you can able to access the Azure Databricks. So once we access this Azure Databricks, what all things you can access? You can access folders. Inside these folders, you may have a subfolders or files. In those subfolders files, you may have a data. So in each and every file, we will have a some data objects. And from the once we access Databricks, you can create the clusters as well. So all these things you can able to access it by from the UI. By using user interface, you can able to access all of these things. Okay, this is one of the way. By using this, you can able to access your Azure Databricks. The second way is by using REST API. So you can use some URLs. If you just access that, like if you try to access that particular URL, what happens is you can able to create your Databricks, and you can able to create cluster, you can able to upload some data by using those URL. Okay, so Databricks REST API allows you to programmatically access Databricks instead of going through the web UI. Suppose you are good at coding, so you can go and access this particular Databricks through programmatically access Databricks instead of going through the web UI. Here we are going through the web UI to access Databricks. Here we are using program to access our web UI. Okay, Databricks has two REST APIs that perform different tasks, 2.0 and 1.2, and 2.0 mainly for the administration task, and 1.2 for the like directly if you want to look at cluster and data upload, all those things, you can use this 1.2 and 1.2. 2.0 for the administration task. So you can see here in 2.0, use the REST API 2.0 for cluster and library management. What is cluster? So whatever servers you need for processing your data. What is library management? Whatever predefined code we are going to create with the help of a predefined code, we will create a library. This particular code we will use to implement our project requirement. Okay, now REST API 2.0 you are using for cluster and library management. So why can't 1.2? Why you are not using 1.2? Because 1.2 cluster management and library management APIs ended on December 31st, 2017. So on in this particular date, from that particular date onwards, API REST API 1.2 is not supporting cluster and library management. That's why we mandatorily we need to use the API 2.0. But 1.2 you can use for other things, and 2.0 you can use for cluster library management. Along with that, you can also use for the administration task, okay, to control the permissions, okay, all those things. Next, so sample URL. So this is the sample URL if you want to like create the or access the Azure Databricks. Okay, if you want to access the Azure Databricks, so this is the sample URL. Next, CLI. The third way is by using CLI. CLI, an open source project hosted on GitHub. The CLI is built on top of REST API 2.0. Okay, 2.0. So on top of REST API 2.0, CLI is built. Now, so how you can access your Databricks? For that, you need to install the CLI. Okay, Databricks CLI you need to install. How you can install? Pip install Databricks-CLI. If you submit this, automatically CLI will install. Okay. So Databricks interface we can access by using three ways. One is user interface, that is web UI. Second is REST API. In REST API we have two ways. One is REST API 1.2 and REST API 2.0. We have seen some functionalities is not working in REST API 1.2, so that's why we are using REST API 2.0. And as we know, whatever latest update comes, you try to use the latest things, because whatever security improvements and other improvements they will do, and they will release the new versions. So that's why we will try to use the REST API 2.0 for accessing our Databricks. Next, CLI. CLI is built on top of REST API 2.0. And how to install the CLI? This is the command pip install Databricks-CLI. Okay, clear? Any doubts in this particular slide? Any doubts in this slide? Lakshman is clear. Senthil sir, Ram.
Yes.
Clear.
Okay, thank you. So we are accessing Databricks by using UI, REST API, and CLI. So this is with respect to interface. Now let's go to the workspace. Okay. Databricks Workspace is an environment for accessing all of your Databricks assets. What is your Databricks assets? Example, you know, all notebooks is main asset, right? Because by using notebooks only you are going to write the code. Next, whatever libraries you need for writing your code and executing your code. So all those libraries, what we need to do is we need to organize all of those things. For organizing all these things in a different folders, we have a workspace. Databricks Workspace is an environment for accessing all of your Databricks assets. What are those assets? You can see. The workspace organizes objects such as notebooks, libraries, and experiments. Whatever experiments we have created for machine learning, those experiments, all these you can able to manage with the help of folders. And then you can grant the access, okay, provide access to data and the computational resources such as clusters and jobs. Once we have organized data into once we organize notebooks, libraries, experiments into folders, we can grant the permissions, we can grant the access, who can access which folders, who can do what kind of things. Example, I have given a access to access folder 1. So inside folder 1, what kind of things they can do, whether they just have to read the data, whether they can remove, they can delete some data, they can download that particular file. So all those permissions we are going to control. Not only that, by using a workspace, you can also provide access to data and computational services such as clusters and jobs. By using workspace, what we are doing, we are organizing all the notebooks, libraries, and experiment. Along with that, you are also granting the required permission for your data, required permission for your cluster and jobs. Okay, all those things you can able to do it from the workspace. Next, in a workspace, we will have a first tab called dashboard. It's dashboard. What it will do, basically an interface that provides organized access to visualization. So So when you open your Databricks, first tab itself, you will have a visual representation of all the assets. Example, if you want to upload any library, you will have an option. If you want to create any notebook, you will have an option to create notebook. If you want to create any cluster, you will have a option to create cluster. If you want to upload some data, you will have an option to upload data. So all the assets you can able to access it from the dashboard. Okay, it will be there in a visual representation. Now let's go to notebooks. What is notebook? So notebooks you have created from dashboard. From dashboard you can create a notebook. Once you created the notebook, how you can access this notebook? A notebook is a web-based interface to documents containing a series of runnable cells. So I hope yesterday I have shown you to show you magic commands, right? So what happens in notebook, you'll have a multiple shells. So we have seen first cell by default. When you create a Python notebook, all the cells by default Python cells. If you want to change default behavior, default Python language to Scala, then you need to put %Scala. If you want to change it to SQL, %SQL. So likewise, so we have a series of runnable cells. In those series of runnable cells, in any of the cell, if you want to execute any other language code, you can execute by using a magic command. That also we have seen. But what is notebook? Notebook is a series of runnable cells that operates on files and tables, visualizations, narrative text. So you can write your code and you can create a dashboards there. We have, so I will show you. You can with the help of data, whatever resultant data, with the data you can even create the reports. Okay, some kind of a visualization you can able to do it within the notebook. Next, commands can be run in sequence. Whatever code you have written in those cells code you can run in a sequence. When you click on run all, it will execute first cell. Once first cell is executed successfully, it will execute second cell. Once second cell is executed successfully, it will execute third cell. Likewise, sequence it will go. Okay. Now what happens is sometimes whatever output you got it in a first cell, you need to take this particular output for processing at the third cell. Example, we will go with a few examples. Okay. I am just with the help of whatever parameters I have received to my notebook, I am going to form my final path for accessing my data or file. Okay, so dynamically I will pass the path from which data lake storage path it has to access the data. So I will read this path and I will create a final path. Maybe whatever path I have received for that, I will add some more partition folders, example 2020, and some other folders I will add to the path, and finally I will create my final path in a first cell. This particular path I need to use to read the file. Okay, I'm going to use this particular path or this particular file location I will use to read the actual file. Now in first cell what I have done, I have created this path. In third cell what I need to do is I will take this URL to read the data. Example, if I want to read CSV file, spark.read.csv, and you can give the file location. That's how you can able to read. Okay, there are different syntaxes, but this is one of the syntax you can use to read the data. So that's how you can able to refer the output of one cell in the another cell. You can say commands can be run in sequence and referring to the output of one or more previously run commands. Okay, 1 and 2 command output you can use in the third command or third cell. Next, libraries. So as we just discussed, library makes third party or locally built code available to notebooks and jobs running on your cluster. So what happens is sometimes all the things may not be available in Databricks, right? You need to download some third-party libraries. So when you download third-party libraries, then you can able to implement some functionalities. So all those libraries also you can able to manage it from the workspace. Next, data. So data you are going to manage it here in a with the help of file system, database, tables. Okay, so with the help of all these things you can able to manage the data. You can import data into a distributed file system mounted into a Databricks workspace. What is the distributed file system mounted? Blob storage. We have a blob storage already available. Whatever data you are importing into this distributed file system, the data will be loaded into the blob storage. but this blob storage is abstract layer. That's why you will not know this is blob storage. But when you create Azure Databricks, you will come to know, okay, it has created a blob storage in backend. You can able to see the high level folders, but you cannot see what was there inside those folders. Okay. Next, work with it in Databricks notebooks and clusters. So with this data, what you can do, you can work within the Databricks notebooks and clusters. And you can also use a wide variety of Apache Spark data sources to access data. Meaning, what are the different data sources you have? You no need to use a Databricks file system, which is default storage from the Databricks. You can even read data from the data lake Gen 1, data lake Gen 2, from another blob storage, SQL database, SQL data warehouse. Okay, that is nothing but Azure Synapse Semantics. You can read data from a different Spark data sources. Next, jobs. Jobs are one mechanism for running code or scheduling jobs in a Databricks. As I said, jobs where you are going to schedule your notebooks. It can be a notebook, it can be your Python file, it can be jar file. All those things you can schedule it to run on a fixed time. Okay, or maybe on demand. Jobs are one mechanism for running code. So entire code is you are going to run it with the help of jobs. And as I said, you can schedule these particular jobs when you want to run these particular jobs. Next, experiments. A collection of machine learning flow runs for training a machine learning models. So what you need to know is you need to define a machine learning flow to train a model. Okay, so which algorithm I need to use to train this model? So all those things I need to define the flow. Once I define the flow, I'm going to start training the model. For training the model, I need to have a ML flow ready. Okay, if you are keeping that particular flow is ready, it's nothing but an experiment. Once experiment is ready, by using that, you are going to train your model. Okay, any doubts in this?
I'm okay.
Any doubts in this? Okay.
Coming to the data, Malaya, can you go through the data once? Yeah.
Yeah, see, data, what you can do is, data you can upload in a DBFS, that is the local file system to your Databricks, Azure Databricks. Second is you can access data from different storages, data like Gen 1, Gen 2, as we discussed, you can mount those storages and you can access it. Okay, so we have already done it when we were learning ADF, right? We have done those things. Okay, so you can able to read the data from different sources, or still you want to maintain some kind of configuration file local, like in Databricks file system itself. Still, those files you can upload in a Databricks file system and you can manage them. Okay, meaning DBFS, within DBFS you can data and other data sources you can manage your data. Whatever data you are managing in different sources, you can able to process it by using Azure Databricks. Okay, and this data in Databricks, we are going to store it in a files. We can store it in a tables. We can also create a tables. Okay, and we can create different folders for maintaining data within the DBFS, Databricks file system. So that I will show you how you can create a folders, how you can create files within the DBFS. Okay, we have a session on that as well.
Okay then, thank you.
Malaya, so you're saying like a DBFS, right? So still that will point the Azure blob or some other storage, right? Or internally it is maintaining Databricks.
Yesterday we have seen Azure Databricks architecture. So there we have DBFS is pointing to your blob storage, which is a default blob storage, which will be created when you launch your Databricks workspace.
Okay.
Create a Databricks, automatically blob storage it will create. In that blob storage, all the data which you are uploading in DBFS will store. But that you will not be able to see it if you open a blob storage. You can able to see what blob storage it has created, what are the folders available inside those, inside that blob storage. But those folders you cannot open to see what is there inside those folders.
Okay.
Okay, any other questions here? Clear on this workspace?
Yeah, and the notebook is similar to like Jupyter notebook kind of stuff, right? It's a runnable cell.
Yeah, it's a interactive workspace, right? So where you can submit piece of code and get the result immediately. Okay.
So if you want to run multiple languages, for example, Python or any other submitting languages, so we need to change, right? As you said, Spark, you said like percentage.
Oh shit, yeah. Sorry. So I think for evening batch, I have shown them, but for your batch, let me just quickly show you that. See, basically, when you create a notebook, right, there you can able to execute all type of languages. In a single notebook, you can execute multiple language code. I think, let me show you quickly now. So even if the cluster is not up, no issues. You can say Cloudpandith demo, create cluster, come to here, create a new node. See, this is the workspace. Okay, this is the workspace. You can see, like visually, you can able to upload data here. You can create a blank notebook. Okay, then here you see you can create a cluster. You can import any library if you have. By using this tab, you can able to create the cluster. By using this tab, you can upload some data, whatever data you are uploading here, where it will store. So this is Databricks community. If it is a community, means where it will store. Yesterday we have discussed
AWS,
community,
right?
very good. So community data, it is more, it is referring AWS S3. If it is Azure Databricks, that will refer blob storage. Okay, click on this. Now click on new notebook. Let's say this is some test notebook. So in which language I'm writing this? Python. Like I'm creating this notebook for Python, and in this particular cluster I want to run this, create it. Okay, already cluster is up and running. I think it is ready now. So come here, you see example, you know, right? This is example a equal to 10. How to define a variable in Python? I hope everybody knows a equal to 10. So this is all. Suppose now I want to define this particular thing, val a equal to 10. So if I try to do it here, it will throw error because in Python it is not valid. Now if you put here percentile scalar, now you see it's a magic command. By default, all these cells are Python cells because we have created a Python notebook. When you create Python notebook, all these cells are Python cells. Now I want to change this behavior to scalar code. How you can do that? Percentage scalar. Now if you want to put here, what you can do, percentage SQL. If you want to do, yes, you can able to do select. Okay, maybe you can say select current underscore date. For this you need to import a this particular function, I guess. Okay, let's see. Yeah, so you can see current date it is giving. This is what select statement. It's a SQL. Suppose if I remove this, if I try to execute, it will throw error. It's not a SQL, it's Python now. In Python it is not allowed. As I said, percentage SQL, it is okay. Okay, current date it is giving. Okay, this is scalar, this is Python, this is SQL. Even you can use the OR. Okay, in same notebook you can able to do all these things. Now after creating notebook, you realize that by default I don't want Python notebook. I want a like a scalar notebook. I want to change this language. Click on this, change default language. You can change it to the scalar now. Change it. Now you see this is a Python code. Automatically it will detect and it will change to percentile Python. It is SQL, no issue. Percentage SQL is there. This is scalar, it will keep as it is. Okay, this one we did not put. Automatically it understands it's Python, then it will use percentile Python. Okay, so these kind of things we will explore more on these things. Don't worry. Now we will learn theoretically, then we will come back for practical things. Okay, any doubts still? Please let me know if anybody have any
Clear,
questions.
Malaya.
Malaya, the backend is SQL. What is it? The SQL Server or Oracle or DB2? Which SQL is pointing?
No, there is no database now.
There is system commands.
Oh, we have seen percentage SQL. We specified right there in the notebook.
Yeah. So it's not a database. Simple query you are querying, right? This is what.
Okay, that's okay.
This is a predefined function which will give you data. Okay, you are not fetching data from any table or something. Okay, even if you create a table, this table data also available where? In DBFS only. DBFS means where? It is available in a blob storage. So as we are using community edition, this, even if you create a table, the table's information and table data, everything will be available in a S3 if it is a community. If it is Azure Databricks, that will be there in a blob storage. Okay, clear?
Yeah.
No. Okay, I'm just moving to the next slide. Data management. So this section describes the objects that hold the data on which you perform analytics and feed into machine learning algorithms. So how we are holding, with the help of what objects we are storing this data. So we will see. So first thing is a Databricks file system. By using DBFS, you are storing some information. See, file system abstraction layer over a blob store. Okay, it contains directories which can contain files. In this, directory is nothing but a folder. In those files, you can have a files. In those files can be a data files, those can be a library files or images and other directories. Okay, inside a directory you can have a other directory or you can have a files. If it is a file, that file can be data file, library file or image file. And DBFS is automatically populated with some data sets that you can use to learn Databricks. So what happens when you create Azure Databricks, by default you will have some data for learning purpose. So you can use those data sets for learning purpose. Okay, this is the first way. By using DBFS like Databricks file system, you can able to store some data. Next, database, a collection of information that is organized so that it can be easily accessed and managed and updated. Okay, it can be easily accessed, managed and updated. So you can create a, by default you will have a default database. Okay, when you create a cluster you will see some default database. Now what happens when you create, like you can create your own database as well. So once you create a database, you are not going to store data directly in a database, right? You are going to create tables inside database. Okay, a representation of structured data. You query tables with a Apache Spark SQL and Apache Spark APIs. Okay, what it means is you can able to write your select star from these tables, whatever tables you have created, and you can able to fetch the data. Okay, so we are going to store our data with the help of tables. Tables we are going to store it inside database, remember. So all this information, where it will store? It will store in a blob storage. Okay, because our abstraction layer over a blob storage, that's why all our data will be there in a blob storage only. Now metastore. So metastore is nothing but a, when you create a tables, so table structure, schema, and what kind of partitions it is creating for each table. So these partitions is created on what columns. So all this information will be available. Okay, this metastore is also available in a blob storage. See, the component that stores all the structured information of the various tables and partitions in the database, including column and the column type information. Okay, so various tables information we are going to store it, and it can be a partitions in the database, including column and column type. On which column you have created a partition, this column, what is the data type of this column. So all that metadata information we will have here. Okay, clear? Any question in this particular slide? So we are going to hold our data by using files. It can be any type of file, but those files we can upload directly in this file system. If you want to store some structured data in a tables, then you can create a database. In that you can create tables and you can store the data. When you create tables, that metadata about this table schema and partitions about each table and partition created on what column, what is the column data type, all that will be there here. Okay, so this is the flow you need to remember. Okay, any doubts here?
Okay.
Okay, Malaya.
Okay, let's go to the next one. Okay, computational management. Here, first one is computation management means cluster. Okay, cluster is nothing but a set of computation resources and configurations on which you run notebooks and jobs. Okay, if you want, we are going to write a code in the notebooks or Python files or scalar, multiple scalar files. You are going to jar. You are going to create a jar out of multiple Scala files. Now you can execute your code in these three ways: Python, jar file, and notebooks. So these all code where you are going to execute. You are going to execute this entire code with the help of a cluster, computational management. That is nothing but a cluster. What is cluster? Cluster is nothing but a group of servers. Okay, so with the help of this group of servers, you are going to run notebooks and jobs. Jobs is nothing but a same code. You are going to schedule it based on fixed schedule time. You are going to run it. Normally, if you are running notebooks, means while you are developing the code, you keep on running to check whether this functionality is working or not. Okay, so likewise, there are two type of clusters: all-purpose cluster and job cluster. So this is very important interview question as well. So multiple times I faced this interview question. Okay, so people will ask you how many different types of clusters available in Databricks. So one is all-purpose cluster, second one is job cluster. What is the difference between these two? Job cluster means you are not creating this cluster. This cluster will be created when you want to run a job, and this cluster will be terminated automatically once your job is finished. Okay, all purpose cluster means you are going to create a cluster and multiple people can use same cluster to execute different code. Maybe data science person, data engineer. In data engineer, you will have a different people, developer 1, developer 2, team lead. So all multiple people are going to use this all purpose cluster to execute your code. Okay, next, whatever cluster you have created, that is all purpose cluster, this cluster you can terminate it, you can restart it. But if it is a job cluster, you will not have any control on it. It will be created when you want to execute a job. It will be terminated automatically once job execution is finished. Okay, so now you don't have option to restart this job cluster, but you have a option to restart all purpose cluster. Okay, clear on that? So let me just give you, see, you create an all purpose cluster using the UI, CLI or REST API. By using these three options, you can able to create the all purpose cluster. Okay, you have created a all purpose cluster. You can manually terminate and restart an all purpose cluster. You have a control on this all purpose cluster. You can terminate it, okay, as per your requirement. When you want again, you can start it again. Okay, next, multiple users can share such clusters to do collaborative interactive analysis. Okay, you have data engineer, data analyst, data scientist. So all these three people can share same cluster which you have created. That's why the name is all purpose cluster. It will operate on all the requirements. Example, for data engineering notebook, it can able to execute. Data science notebook, it can execute, and data analyst notebook, it can execute. Okay, next, let's go to the job cluster. The Databricks job scheduler creates a job cluster. So who is going to create job cluster? We are not creating. Automatically, Databricks job scheduler creates this job cluster. When you run a job on new job cluster, which is created by Databricks job scheduler, what happens is it will create a new cluster and it terminates the cluster when the job is completed. Once the job is completed, this cluster will be terminated automatically. Next, you cannot restart a job cluster. You cannot restart a job cluster. Why you cannot restart? Because on this particular cluster, you will not have any control. Okay. Next. So there is a concept called pool. You need to understand what is pool. So basically, an instant pool API allow you to create, edit, delete, and list instance pools. What it means is, instance means what? One server. Instances means multiple servers. So instance pool means something group. Instance pool means servers group. You are going to keep a multiple servers at one place. That one place you are calling it as an instance pool. Why you are maintaining this instance pool? I will tell you. Now, what happens when you create a cluster? You are going to request for 8 node cluster. 8 node cluster means you need 8 servers. Now, if you need 8 servers, if you go to the cloud provider, whoever is providing these services, you need to search for these servers where these servers are available, right? It is going to take some time to search. Then you need to get these servers. After searching these servers, wherever available, you need to get those things. Then you need to start it. It is two process. First thing is you are searching. Then once you get the instances, you are starting. But if you maintain all the instances in the pool, what happens is you don't need to search it directly. When you need 8 nodes, 8 servers, go to pool and pick those eight servers and start them immediately. Once your work is done, okay, once your work is done, you have 8 servers available now. These are you don't want to run. Now, when you terminate it, these nodes will go and sit it in the pool. If somebody else is creating another cluster, these 8 servers already available here because I have returned them back. These 8 servers now available again in the instance pool. If somebody else is creating a cluster, is requesting for 4 nodes, then 4 nodes will go and 4 nodes still will be there in a pool. And whatever servers we have in the pool, those are idle. Those are not running. Okay. Got it, friends? Now, there is one scenario where your instance pool has 8 servers, but you need 10 servers. In this case, what is going to happen is your instance pool will provide all the 8 servers to you. You can use it, and the instance pool will go to the cloud provider, wherever instances it can get. Okay, instance providers. It will go to instance providers and it will try to take 2 more servers. And whatever 2 more servers it got, those 2 servers also it will try to give you. But now it is going to take more time because pool has to get it from the instance provider. Once it got these servers from instance provider, from there we will get these pools. We will get these nodes. Okay, got it. So let me show you the this theory part. Instance pools API allows you to create, edit, delete, and list instance pools. Meaning you are going to maintain a multiple instances. Those new instances you can create in it. You can edit the existing instances. You can delete the existing instances. Everything you can able to do. Now, a set of idle, ready to use instances. Instance means servers. A set of idle, ready to use servers that reduce cluster start and auto scaling times. Auto scaling means what? On demand. When you need more servers, you are going to fetch it more servers for processing your big data. So here, whatever servers are available in your pool, all those are idle and ready to use. All are active. Okay. When attached to a pool, means when you attach a server to a pool, a cluster allocates its driver and worker nodes from the pool. Okay. See, when attached to a pool, now when you are creating a cluster, you will say a cluster, this cluster while you are creating, you have attached to the pool. Now what happens? This cluster allocates driver mission and worker nodes, all these things from the pool. But if you're not selecting this pool while you are creating cluster, then what happens? This cluster will not try to get the instances from the pool. While you are creating cluster, you need to attach this pool. Okay, you may have a multiple pools. In which pool you have available instances, you can select that pool to get the instances such as driver nodes and worker nodes. Next. If the pool does not have sufficient idle resources, as I explained, you need 10 servers, but pool has only 8. What will happen in this case? Idle resources, okay, does not have sufficient idle resources to accommodate the cluster request. Okay, accommodate cluster request. It doesn't have sufficient services. Then what happens? Servers. The pool expands by allocating new instances from the instance provider. Whoever is providing these instances, it will go there and it will try to get the new instances. Okay, next. When an attached cluster is terminated, okay, if the cluster is terminated, the instance it used are returned to the pool. The instances which is used by this cluster will return to the pool. We will return those instances or servers to the pool and can be reused by a different cluster. Maybe if somebody else is creating another cluster, that cluster will consume these instances. Okay, next. we have something called job. So job, we just have seen, it's a job and non-interactive mechanism, because you are not going to get a result bit and pieces, right? It will execute entire code at once. When you schedule a job, entire notebook will execute. You are not going to stop, okay, I want to execute only till 5, then I will check the result. Can you run after I check the result? That is not possible. It is going to execute entire code at once. That's why it's a non-interactive mechanism for running a notebook or library, either immediately or on a schedule basis. If you want to run immediately, you can run immediately, or if you want to run on a schedule base, you can run on schedule base. Okay. Any doubts here? See, cluster is nothing but a group of servers. Here, two types of clusters we have: all-purpose cluster and job cluster. All-purpose cluster you can use used by multiple people, data engineers, data scientists, data analysts, for different purpose. And job cluster will be created automatically by Databricks job scheduler when you want to run any job. Once job execution is finished, this job cluster will be terminated. Pool is nothing but where we are going to maintain the instances. Okay, before you create the cluster, you are going to maintain the see, why all companies are maintaining the bench. Okay, why they are maintaining bench people? Because when they get project, immediately they can get the resource for working on those projects. If they don't have these people, first they need to search the people from the market. So once they search for people, they have to take a lot of things, right? They have to take the interview, then these people may join or may not join. So likewise, we will have a lot of issues. That's why you are going to maintain few people in the bench. In the same way, some instances we are going to maintain in the pool. When you have some requirement, you want to create a cluster, quickly you can go and get the resources or servers from the pool, so that you can start cluster quickly for processing your data. Job is nothing but you can run your notebooks or Python file or jar files quickly in a non-interactive mode. It may be on schedule based or immediately. Okay. Any questions here?
Malaya, one question. When you said in the pool, a cluster allocates, when attached to a pool, a cluster allocates its driver and worker node from the pool. I mean, like allocates its driver in the sense, I didn't get it. Like,
see, if you remember Spark architecture, which I have explained, you will have a driver and workers. Driver will take entire task and it will divide a task to the subtask. These subtasks it will give to the workers. Let's imagine we have a manager. Why we have a team lead? So team lead is going to take entire work and he will distribute to the actual developers, because whatever he will see, okay, he's junior, he can do this work, and he's a little bit senior, he can do this work. So team lead is going to decide what kind of task he has to assign to which developers, right? So in the same way here, what happens is we will have a lot of servers. We are going to collect, like we are going to take all these servers. For driver nodes, we will take server from pool, and for worker nodes also we are going to take a servers from the pool. What it means, just imagine, whether team lead or developer, all are humans. In the same way, all servers available in this pool. Some server you will take it and work, you will operate it as a driver node, and other servers you will operate it as a workers. Driver, where you are going to like manage all the things, you are going to submit all your code on driver. Driver will take this task and divide the big task into small task, and the small task will be submitted on the worker nodes. Okay, this, if you want to understand, you need to understand the Spark architecture. Okay, drivers and worker nodes. If you'd like to see that, let me quickly show you. See your driver program you have. Okay, driver. These are two workers. So total 3 servers. One is driver, 2 are workers. Workers can be actual task you are going to execute with the help of workers. Okay, but now even driver also can able to execute your task. But a driver is mainly a kind of a head who will get the result and display the result. Okay, it is the kind of a manager who will manage all the things here. Okay, workers are just, these workers will execute this task. That's all. Whatever task is received by workers will execute that task. That's all.
Clear, Malaya.
Okay. Yeah, you will get to know more when we discuss Spark architecture. Okay.
Okay.
Yeah, so Shashi is asking, in real time, generally does people create direct clusters or do they create pools and configure clusters from the pools? So that's what we are saying. Generally, what they will do is they will use pools only. Why they have to use pools? Because if they use pools, the cluster start time is less. And next thing is, you may think, right, if you take all these servers and if you maintain in a pool, it is cost. There is no cost involved because whatever servers you are maintaining in pool, all those are idle cluster. Those are not running cluster, stopped clusters. Okay, that's why there is no cost involved in that. So that's why you always, if in your project, if they are not using pools, then you can suggest them to use the pools. Okay, because there is no cost involved with that. But you will get a better performance and you can quickly, not a performance, but when you go for lunch and come back, you want to work immediately. But what happens? You will start cluster. It will take 5 to 10 minutes. Okay. In meanwhile, you will start something and you will stuck there, and whatever work you thought of doing now, you will forget. Okay. If the cluster is going to start immediately within 1 or 2 minutes, it will be like you can able to start working on these things quickly, right? Understood, everybody? Okay.
Yeah,
Clear
Malaya.
on. Senthil, are you clear on this, or you have any question?
Yes, Malaya. Yeah.
Okay. Thank you. Let's go. So in the same computational management, we have few more things that we need to discuss quickly. Let me go. So computational management, we have a next thing is Databricks runtimes. So the set of core components that run on the cluster managed by a Databricks. So what happens when you are creating a cluster, you need to select the Databricks runtime. Okay, what is this Databricks runtime? It's a core component that run on the cluster. Meaning, suppose core component means suppose I want to submit my machine learning program. For submitting machine learning code, I need some predefined modules. Okay, modules already available. Those modules I need to install. Instead of installing those modules by me, if you select a proper Databricks runtime, in that runbook itself will install all the required modules on the servers. What are those servers? Whatever we have discussed as of now, instances. On those instances, required modules will be installed. Okay, Databricks offers several type of runtimes. The first runtime is Databricks runtime. Okay, it includes Apache Spark, but also adds number of components and updates that substantially improve the usability, performance, and security of big data analytics. So let me show you quickly. If you come here, here, go to cluster, click on this cluster. You can see there are different. Click on edit. You see there are different Databricks runtimes. What it indicates? So you have 7.3, 7.2, but there is no difference. Just Spark 3.0.1 we are using in this runtime. So these kind of updates. See here, you are using 7.1 and 7.2. You don't have any difference. You see here. So, but we will suggest you to use 7.2. Why not 7.1? Because when they introduced 7.2 means they have improved some security things or some processes, some other things they have backend they have improved. So that's why always suggestible to use the latest Databricks runtime. And when you select 7.3, in 7.3 itself you have 3 runtimes. In 7.2 you have 3. 7.1 you have 3. If you consider anything, you will have a 3.3. Why 3.3? See, if you select 7.3 with this one, you will not get machine learning modules. Okay, if you select this, you will get a machine learning module. Suppose you want to process your machine learning data or some models you want to execute on this cluster, then you have to select this particular runtime. You want to process some some medical data, okay, graphical data, in all those things, then you have to go with the GPU and ML. Okay, scale and Spark, all this will come. So likewise, based on the requirement, you need to select the Databricks runtime. So basic Databricks runtime is 1 second. So the basic Databricks runtime is 7.3. As of now, we have a 7.3. This is the basic Databricks runtime, means it's a basic. Next runtime is Databricks runtime for machine learning. We have a ML runtime, right? What this ML runtimes will have is, it is built on Databricks runtime and provides a ready to go environment for machine learning. If you want to execute a machine learning, you need some kind of environment, machine learning environment. If you select this runtime, ready to go environment for machine learning is available. Then you can immediately execute your data science notebooks and your Python files or Scala files which you have written for your data science models. Okay, it contains multiple popular libraries including TensorFlow, Keras, PyTorch, and XGBoost. So all these modules, all these libraries already available if you select this runtime. But if you select this runtime, these libraries will not be available. Explicitly, you need to install all these things. Why you need to do this? If you select a proper runtime, automatically all these libraries available. Okay, and it is going to give you latest version softwares libraries. Next, Databricks runtime for genomics. So that's what we have seen, right? It is a version of Databricks runtime optimized for working with a genomic and biomedical data. If you want to work with biomedical data, okay, then you need to use this particular runtime. We have seen 3 types of runtimes, right? But one more runtime we have that is not available in Databricks community, that is Databricks Lite. Why this Databricks Lite is? This is basically to execute our Python files and Scala code. Okay, only those things you can execute, but notebooks you cannot execute on this runtime, Databricks Lite runtime. Okay, this Databricks Lite runtime will not support notebooks. It supports only Python and jar files, meaning Python and Scala code. But it will, when you don't want to worry on performance and reliability, auto scaling benefits, then you can go with the Databricks Lite. Okay, see, provides a runtime option for jobs that don't need the advanced performance, reliability, and auto scaling benefit provided by Databricks runtime. You can select Databricks Lite only when you create a cluster to run jar, Python, or Spark Submit job. It's not for notebook. See, you cannot select this runtime for clusters on which you run interactive or notebook job workloads. Okay, if you want to run any notebook, then you should not use Databricks Lite runtime. Okay, clear? Just 5 more minutes. Okay, don't worry. Workloads. So there are 2 types of workloads. One is we just have discussed, right? With the help of job cluster, you can submit some workloads. With the help of all-purpose cluster, you can submit some workloads. Most of the data engineering workloads we will submit with the help of a job cluster. Data analytics workloads we will submit with the help of a interactive workload. What is interactive workload? It's nothing but a all-purpose cluster. Here we will use a job cluster. Next, we will have a execution context. It's nothing but a REPL environment for each supported programming language. What is REPL? Okay, so read, evaluate, print, and print loop environment. Okay, so for all these languages, you need to read some inputs and you need to display some data, you need to loop through some values. So such type of environment we are going to have in Azure Databricks. Okay, such kind of REPL environment is created for all the languages such as Python, R, Scala, and SQL. Okay, any questions in this particular 2 slides? Previous one and this one. Can you confirm?
I'm not clear about this workload and execution context.
Okay, so workload is, see, workload means how you are submitting jobs, right? So data engineering, they will write some code for their purpose, and the data analytics team, they will write some code for their purpose. Now, most of the data engineering works, we are going to schedule them with the help of a job cluster. Okay, data analytics means what? They are going to analyze the data, maybe with the different parameters they want to see. If we change this, what will happen? So it's a interactive. When it is interactive, you have to run it with the help of all-purpose cluster. If it is data engineering, so they will just write some code for doing these fixed transformation, and once they get output, these output they will write to somewhere. Okay, such type of things they can schedule it with the help of job cluster, meaning they can run that particular code with the help of job cluster. Okay, so that is the workload. Execution context means to execute Python code, R code, Scala code, and SQL code, whatever environment you need, whatever softwares you need, whatever binaries you need, all those are already available. So that's why you are able to execute all these languages in a notebook that is nothing but in Azure Databricks.
Yeah.
Okay, environment for executing all these different codes available with the help of execution context. Workload is nothing but how you are submitting your work. If it is a like fixed transformation code you have already available, then you can go for the job cluster. You can schedule it because you don't need to change anything. Data analytics means you want to tune, you want to change some parameters, and you have to check your like how it is performing, whether it is working or not. Okay, so all those things, if you want to tune, then you have to go for all purpose cluster, because you are keep on executing and you are going to stop in the middle. So depends, right? So that's why it should be interactive. Here you can go for the automated. Okay.
Yeah.
Any other questions, friends, in this particular slide?
No, clear.
நீ போ இது என்ன பழக்கமே வச்சுக்கிட்டியா நீ சும்மா அப்புறம்
Okay, let me go here. Model management. Okay, so in this model management we will have all things with respect to the machine learning. Okay, this section describes concepts that you need to know to train machine learning models. So first thing is model. So model is nothing but a, you are going to have a what kind of algorithm you need to use. Okay, some kind of predictors and outcome. So what is predictors and what is outcome? Predictor is nothing but a, you are going to predict something, it is going to happen. So when result comes, your actual outcome will come. Okay, you have predicted something. Example, you are predicting today evening it will rain. Okay, you just prediction data you have. Now outcome came today evening, maybe tomorrow. When you think about tomorrow, already you got the outcome. So it might rain, it may not be rain, right? So in that case, you have to just compare between these two, predictor and outcome. So what is the relation between these two? Whether whatever you have predicted, same you got in the output or not. What is the percentile change? All those things you need to change. You need to check. Mathematical function that represent the relationship between a set of predictors and an outcome. You train a model using an existing data set, because with the help of lot of data you will train. Okay, so maybe since last 10 years, yeah, October 7th evening every day it trained. So we will train with all the existing data. Now you will ask mission will, what mission will tell in 2020 or in 2020 also, on October 7th evening it will rain, it will tell like that. Now on that particular evening you will get to know the actual output. Okay, then use that model to predict the outcomes of new data. So what is new data? New data means whatever happened today evening, you will get that new data and you have to compare with that. Okay, model to predict the outcomes. What is prediction of outcome? Meaning first you have predicted, what you have predicted is it may rain today evening. That's what you are going to predict with the existing data. So after that, with new data you are going to get the outcome. Once you get the outcome, you need to like compare predictors and outcomes. Okay, next run. Suppose if you want to run any model, you need a collection of parameters, metrics, tags related to training a machine learning model. So you are going to pass all these things while you are running a model. Next, you will have an experiment. So experiment we already discussed, right? So what you are going to do, you are going to define a flow. Okay, to train a model or to score the model. What is scoring? Scoring yesterday we have discussed, right? So with 1000 apples you will train a model. When you pass 1001 apple, it will give you, it will try to answer it is apple. It may tell it is apple, it may not tell it is apple. So based on that you need to give the score. But in real time what happens, example, you have a lot of data set which is telling you that this guy is good guy, you can give the personal loan. This guy you can offer the personal loan. How much loan you can give? So all those things it is giving. So based on that, what you are going to do, whatever information we have in the past, all the data you will ingest to the mission will predict whom you can offer personal loan, whom you should not offer the personal loan. Now with the help of this prediction you will grant a personal loan. But after granting personal loan, what happens? Some people will pay, some people will not pay. So then you will come to know whatever you have predicted, what is actual outcome. Maybe 10 people, you thought of providing personal loan to 10 people, you trust these 10 people, but when you have provided a loan, personal loan to these 10 people, only 5 people are paying, 5 more people are not paying. Now 50% scoring, because our model got only 50% score. Why? Because whatever this model given result, out of which, out of 10, only 5%, like 5 only correct. 5 only correct means 50% only correct. Out of 10, only 5 is correct means what? 50% correct. Okay, all that flow and scoring, everything we are going to do. For that, we need to create an experiment. Okay, the primary unit of organization, access control for runs. All ML flows run belong to an experiment, because all ML flows run belongs to an experiment. What is experiment? That's a flow. Okay, an experiment lets you visualize, search, compare runs, as well as download run artifacts or metadata for analysis in other tools. Okay, so it will allow you to visualize. So you can go to each activity which you have used in your flow and you can visualize what is the output, and you can search for some parameters. So in output, whether I am able to see this particular person record or not, and you can compare with other results. Okay, maybe you can compare with the different algorithm result, and you can download the dependency things, and whatever metadata you have, all these things you can able to download, and you can test it in the, like test it with the other algorithms as well. So whatever algorithm you think correct, you can go with that algorithm. Okay, so but don't worry, we are not going to use much machine learning. We are going to focus mostly on data engineering. Okay, let's go to authentication and authorization. So here this section describes concepts that you need to know when you manage Databricks users, their access to Databricks assets. So here we are going to like control access by using two things. One is per users, per groups. Okay, finally you are going to control with the help of ACL. Okay, access control list. So now first one is user. What is user? Who is user? A unique individual who has access to the system. So you can grant access to the directly user, or this user you can add to the group. Okay, collection of users, you can keep it in a group, maybe data engineering group, data science group. So whatever permission you need to give for data engineering, so all that permission will be granted automatically if you add this user to this group. But if you want to give a unique permissions to this user, independently you can give the access to this user. Okay, he is a data engineer guy, but he is team lead. You want to see some data science notebooks. Yes, you can give permissions independently. But for this same data engineer person, if you want to give a permission, you no need to give separately. You can add this person to group. Already data engineer group, it is available, and this group has full permission. If you add this person to group, ultimately this user also will get to see all data engineering notebooks. Next, access control list. So with the help of access control list, you can give like access what they can do, like what notebooks they can see. Okay, what access they have. So once they have access to what they can do, example, whether they just can read the data, they can delete the data, they can modify, or so all those things you need to take care with the help of ACL. A list of permissions attached to the workspace. You are going to attach to the workspace, such as in Workspace. Not only Workspace, you can attach to clusters, jobs, tables, or experiments. Okay, list of permissions you are going to attach to all these things. And ACL specifies which users or system process are granted access to the objects. Okay, so ACL, what ACL is specifying, ACL tells you which users or systems granted to what objects. Example, you have a data engineering guy. For this person, you are just granting access to access the data engineering objects. So likewise, you can grant the access to the required objects, as well as what operations are allowed to the asset. So once they can able to see the notebook, what operations they can do on that asset, whether they just to read the data, they can modify, they can delete, what all things they can do, that operations you are going to define. Each entry in a typical ACL specifies a subject and an operation. Subject means what he can access. Okay, an operation is nothing but once he has accessed, what all operations he can perform, whether he just has a read access, whether he has the edit access, whether he has a create access. So all that operations you will have. Okay, here you are going to control permissions, but you can grant these permissions directly to user. You can grant these permissions to group. Okay, clear on this? Any doubts here?
Clear.
Okay, so that's all for today, friends. Okay, thank you.
Thank you. Thank you.